Welcome to Astronomy Daily. I'm your host, Anna, and today we're embarking on a cosmic journey through the latest breakthroughs and discoveries in our vast universe. It's an exciting time for space exploration, with NASA's Parker Solar Probe about to make another record-equaling close approach to our sun, zooming through the corona at an astonishing 430,000 miles per hour. We'll dive into what scientists hope to learn from this daring mission. Also on our radar is the recently launched Spherex Space Observatory that has just opened its eyes to the cosmos after ejecting its protective dust cover. This innovative telescope is set to map the entire celestial sky in unprecedented detail, revealing secrets about the history of our universe. We'll check in on NASA's EASY satellite mission, which is now operating smoothly in orbit and preparing to study the mysterious electrojets that flow through our planet's upper atmosphere. In more distant news, astronomers have discovered what they're calling space tornadoes swirling around the core of our Milky Way galaxy. These fascinating structures are changing how we understand the turbulent environment surrounding our galaxy's supermassive black hole. We'll also explore groundbreaking research from China's Chang'e 6 mission, which has finally determined the age of the moon's largest impact crater, giving us new insights into the early history of our solar system. Looking ahead to next month, we'll preview NASA's Lucy spacecraft as it prepares for a flyby of an asteroid with a fascinating 150 million year history. And we'll end with some reassuring news about a binary star system nicknamed the Death Star. Spoiler alert, Earth is not in its line of fire after all. So settle in as we navigate through these cosmic wonders and the latest advancements in our understanding of the universe around us. Let's kick things off with some NASA mission updates. NASA's Parker Solar Probe is making headlines once again as it speeds toward another record-breaking encounter with our sun. The spacecraft is currently on its 23rd science-gathering solar mission and is set to equal its previous record of coming within just 3.8 million miles of the sun's surface this Saturday. To put that distance in perspective, that's about 4% of the distance between Earth and the sun. While that might sound like a safe distance, the probe will be deep within the sun's corona, the outermost part of the solar atmosphere, where temperatures soar to millions of degrees Fahrenheit. What makes this achievement even more remarkable is the velocity at which Parker Solar Probe is traveling. The spacecraft will match its previous record speed of 430,000 miles per hour. That's fast enough to circle Earth in just 3.5 minutes or travel from New York to Los Angeles in about 25 seconds. This makes it the fastest human-made object ever created by far. During its closest approach this weekend, the probe will be completely out of contact with Earth. It will be operating autonomously as it collects unique observations and measurements from inside the sun's corona. Mission operators at the Johns Hopkins Applied Physics Laboratory in Maryland, where the spacecraft was designed and built, won't know its status until it transmits data back to Earth on Tuesday. The spacecraft's 4 scientific instruments are primed to gather invaluable data that simply can't be collected from Earth. This is the second of several flybys that will occur at this distance and speed, allowing scientists to conduct unrivaled measurements of the solar wind and related activity. Meanwhile, researchers are still analyzing the wealth of data streaming back from Parker's previous closest approach in December. These consecutive close passes are creating an unprecedented data set that helps scientists understand the complex dynamics of our star. The mission is teaching us about fundamental processes, like how the sun generates the solar wind, the constant stream of charged particles that flows outward through our solar system and can affect everything from satellite operations to power grids on Earth when solar storms occur. By flying repeatedly through the sun's corona, Parker Solar Probe is helping unlock mysteries about our star that have puzzled scientists for decades, including why the corona is hundreds of times hotter than the sun's surface, despite being farther away from the core. The data gathered will help improve our ability to forecast space weather and protect our technology-dependent society from its potential impacts. Next on our update schedule. NASA's recently launched Spherex Space Observatory has reached an important milestone in its mission by opening its eyes to the cosmos. On March 18th, just a week after its March 11th launch into low Earth orbit, mission controllers commanded the spacecraft to eject the protective dust cover that had been shielding its telescope. This crucial maneuver involved activating two mechanical release mechanisms on the protective lid, with springs helping to push the cover away from the observatory. The cover, measuring about 25 inches by 16 inches, had been protecting three critical telescope mirrors from particles and moisture during launch. Once released, the cover began floating away and will eventually burn up in Earth's atmosphere. Since the spacecraft's camera won't be powered on until it reaches its extremely cold operating temperature of below -300 degrees Fahrenheit, engineers confirmed the successful cover removal by detecting slight movements in the observatory's orientation. These little jiggles occurred after each mechanism release, and shortly afterward, the telescope's temperature began dropping. Clear evidence that it was now exposed to the cold vacuum of space as intended. Spherex, which stands for Spectrophotometer for the History of the Universe, Epoch of Reionization, and ICE's Explorer, is surprisingly compact for such an ambitious mission. While the entire spacecraft is roughly the size of a subcompact car, the telescope itself is only about as large as a washing machine. It sits nestled inside three cone-shaped photon shields that protect the sensitive instrument from heat and light coming from the sun and Earth. Once science operations begin in the coming weeks, Spherex will embark on its 2-year primary mission using a technique called spectroscopy to create something truly extraordinary: 4 complete maps of the entire celestial sky, each featuring 102 distinct wavelengths or colors of infrared light. This spectroscopic data will give astronomers unprecedented insights into the universe. The detailed information will help scientists precisely measure distances to faraway galaxies, identify specific chemicals and molecules present in cosmic gas clouds, and potentially answer fundamental questions about the early universe and how it evolved over billions of years. By observing in the infrared portion of the spectrum, Spherex can see through cosmic dust that obscures visible light, revealing details about star formation and the composition of interstellar space that would otherwise remain hidden. This comprehensive sky survey will create a valuable data set that astronomers will analyze for years to come, potentially leading to discoveries we can't yet imagine. And another NASA mission update. In some exciting news for NASA's space weather research, mission controllers have now confirmed that all 3 satellites from the EASY mission are healthy and functioning normally following their March 15th launch aboard a SpaceX Falcon 9 rocket from Vandenberg. EASY, which stands for Electrojet Zeeman Imaging Explorer, represents an important step forward in our understanding of Earth's complex relationship with our Sun. The mission team at Johns Hopkins Applied Physics Laboratory in Maryland received signals from all 3 spacecraft, confirming they survived the launch and deployment phase without issues. Over the next 2 months, these satellites will undergo thorough science and instrument checkouts, a critical commissioning phase that ensures all systems are fully operational before beginning their primary mission. Once this process is complete, EASY will turn its attention to studying one of the most spectacular yet mysterious phenomena in our upper atmosphere. The mission focuses specifically on electrojets, powerful electrical currents that flow high above us in the polar regions where auroras illuminate the night sky. These electrojets are essentially rivers of electricity that surge through the ionosphere, created by the complex interaction between our planet's magnetic field and charged particles from the sun. What makes EASY particularly groundbreaking is its ability to map these electrojets with unprecedented detail. The mission employs a specialized technique to measure the Zeeman effect, a phenomenon where magnetic fields split spectral lines, allowing scientists to precisely track and analyze these powerful currents from space. Understanding electrojets isn't just scientifically fascinating. It has practical implications for our increasingly technology-dependent society. These currents are key components of space weather, which can disrupt satellite operations, navigation systems, power grids, and communications networks. By creating detailed maps of electrojet behavior, EASY will help scientists develop more accurate models to predict when and how space weather events might affect our technological infrastructure. The trio of satellites will work in concert to provide multiple measurement points, giving researchers a comprehensive view of these dynamic electrical systems as they respond to solar activity. This coordinated approach should reveal new insights into how energy from the sun propagates through near-Earth space and ultimately influences our atmosphere and technologies. Now, moving on to other news today. astronomers have made a stunning discovery in the heart of our galaxy, revealing what they're calling space tornadoes swirling around the Milky Way's core. Using the incredible resolution of the Atacama Large Millimeter Submillimeter Array, or ALMA, an international team has sharpened our view of the galactic center by a factor of 100, unveiling mysterious new structures that have surprised even veteran researchers. The central molecular zone surrounding our galaxy's supermassive black hole has long been known as a turbulent region where dust and gas molecules constantly cycle through formation and destruction. But the driving mechanism behind this cosmic churn has remained elusive until now. Led by Kai Yang from Shanghai Jiaotong University, the research team detected previously unknown filamentary structures that don't match any known celestial objects. These slim filaments appear as long, narrow structures that aren't associated with star-forming regions or other familiar cosmic formations, making them a genuinely new discovery. When we checked the ALMA images showing the outflows, we noticed these long and narrow filaments spatially offset from any star-forming regions. Unlike any objects we know, these filaments really surprised us, explained Yang, describing the serendipitous finding that emerged while studying emission lines of silicon monoxide and 8 other molecules. What makes these structures particularly fascinating is their behavior. The researchers have likened them to actual tornadoes in space, violent streams of gas that distribute materials efficiently throughout their environment before quickly dissipating. Unlike other previously discovered dense gas filaments, these show no association with dust emission and don't appear to be in hydrostatic equilibrium. The research team used silicon monoxide as a primary tracer because it exclusively appears in regions experiencing shockwaves. The presence of complex organic molecules like methanol further confirmed that these filaments are likely created through powerful shock processes rippling through the galactic center. Xing Liu, a research professor at Shanghai Astronomical Observatory and corresponding author of the study, explains the significance. Our research contributes to the fascinating galactic center landscape by uncovering these slim filaments as an important part of material circulation. We can envision these as space tornadoes. They are violent streams of gas, they dissipate shortly, and they distribute materials into the environment efficiently. The discovery suggests a cyclical process where these shock-induced filaments release various molecules into the interstellar medium before dissipating. The released materials later freeze back onto dust grains, creating a continuous cycle of depletion and replenishment throughout the central molecular zone. ALMA's extraordinary sensitivity was crucial for this discovery, allowing astronomers to detect these structures on an extremely fine scale of just 0.01 parsec, marking what researchers call the working surface of these shocks. Future observations spanning multiple transitions and broader regions of the galactic center, combined with numerical simulations, may confirm the origin of these slim filaments and better explain the cyclic processes taking place in this extraordinary region of our Milky Way. Next up, Chinese researchers seem to be on a roll, so to speak. Scientists have long sought to determine the precise age of the Moon's South Pole Aitken Basin, the largest and oldest known impact crater on the lunar surface. Now we finally have an answer, thanks to the groundbreaking work of researchers from the Chinese Academy of Sciences, who analyzed the first-ever rock samples returned directly from this region by China's Chang'e 6 mission. The research team, led by Professor Chen Yi from the Institute of Geology and Geophysics, has dated the formation of this massive basin to approximately 4.25 billion years ago. This timeline places the impact event roughly 320 million years after the birth of our solar system, providing astronomers with a crucial reference point for understanding lunar evolution. The South Pole Aitken Basin is truly a remarkable feature of our celestial neighbor. Spanning much of the Moon's far side, this vast impact structure is believed to have formed during the early period of intense asteroid bombardment that shaped many worlds in our solar system. Despite its significance, pinpointing its exact age has proven challenging, with previous estimates varying widely. To crack this cosmic mystery, the researchers meticulously analyzed approximately 1,600 fragments from 2 soil samples returned by the Chang'e 6 mission. Their attention focused on identifying impact melt rocks, which would provide the clearest evidence of the basin's formation. Among these fragments, they discovered 20 norite clasts with distinctive textures and chemical signatures consistent with an impact origin. Using lead-lead dating of zirconium-bearing minerals within these clasts, the team uncovered evidence of two separate impact events, one dated to 4.25 billion years ago and another to 3.87 billion years ago. The older norites, from 4.25 billion years ago, showed structural and compositional features, suggesting they crystallized at different depths within a common impact melt sheet produced by the South Pole Aitken Basin forming event. Our geological surveys and comparative lithological analyses strongly indicate that the 4.25 billion year age corresponds to the formation of the SPA Basin, stated Professor Chen in the research paper published in National Science Review. This discovery provides the first direct sample-based evidence for the age of the Moon's largest impact basin. The precise dating serves as a critical anchor point for refining the lunar cratering chronology, allowing scientists to better reconstruct the timeline of the Moon's early evolution and providing new insights into the dynamic processes that shaped the early solar system. Okay, let's head back to NASA for our next mission update. Next month marks an exciting milestone for NASA's Lucy mission as the spacecraft prepares for its flyby of asteroid Donald Johanson on April 20th. While this encounter serves primarily as a rehearsal for Lucy's ultimate destination, Jupiter's Trojan asteroids, scientists are eagerly anticipating what they might learn from this peculiar space rock. Recent research from the Southwest Research Institute in Boulder, Colorado, has revealed that Donald Johanson is approximately 150 million years old, having formed when a larger asteroid broke apart. This 3-mile-wide object, named after the discoverer of the famous Lucy human fossil, appears to have undergone significant changes since its formation. Based on ground-based observations, Donald Johanson appears to be a peculiar object, noted Simone Marchi, Lucy's deputy principal investigator. Computer modeling suggests that both the asteroid's orbit and its spin have evolved dramatically over time. David Wokrulicki, a professor at Charles University in Prague and co-author of the research, explained that data indicates that it could be quite elongated and a slow rotator, possibly due to thermal torques that have slowed its spin over time. Lucy's flyby will collect crucial information only accessible from close proximity, including detailed data about the asteroid's shape, surface geology, and cratering history. This information is particularly valuable because Donald Johanson appears distinct from other recently studied asteroids like Bennu and Ryugu, which were sampled by NASA's OSIRIS-REx and JAXA's Hayabusa, 2 missions respectively. Lucy launched in October 2021 and is on an ambitious 12-year journey to visit a total of 11 asteroids. After Donald Johanson, the spacecraft will continue to Jupiter's Trojan asteroids, ancient remnants trapped in Jupiter's orbit that scientists describe as fossils of planet formation. Earth-based observing and theoretical models can only take us so far, explained Keith Knoll, Lucy project scientist at NASA's Goddard Space Flight Center. To validate these models and get to the next level of detail, we need close-up data. Lucy's upcoming flyby will give us that. This encounter follows Lucy's previous flyby of asteroid Dinkinesh, which surprised scientists with unexpected features, including its own tiny satellite. Researchers are hopeful that Donald Johanson might hold similar surprises, potentially revealing new connections between different types of asteroids in our solar system. The data gathered will further enhance our understanding of the early solar system's formation and evolution, adding another critical piece to the cosmic puzzle that Lucy was designed to help solve. And let's finish today's episode on a positive note. Good news for Earth. Astronomers have recently determined that the ominously nicknamed Death Star isn't actually pointed at us. The binary star system known as WR104, located about 8,000 light-years away in the constellation Sagittarius, has long concerned scientists due to its potential to unleash a devastating gamma-ray burst in our direction when its stars eventually collide. WR104 contains a Wolf-Rayet-class star with a scorching surface temperature of around 44,000 Kelvin, nearly 8 times hotter than our Sun. This extreme star is locked in orbit with a more massive companion, creating a spectacular spiral dust pattern that resembles a pinwheel. The system earned its sinister nickname because early studies suggested its rotational poles might be pointing toward Earth, raising concerns about a potential future gamma-ray burst aimed directly at our planet. However, new research led by Keck Observatory instrument scientist Grant Hill has put these fears to rest. Using 3 sophisticated instruments at the Keck Observatory, LRIS, ESI, and NIRSPEC, Hill's team made spectroscopic observations that revealed a surprising twist in the system's geometry. While the pinwheel dust spiral appears to be face-on from Earth's perspective, velocity measurements of the 2 stars showed that the actual orbital plane is tilted at least 40 degrees from previous estimates. This significant tilt means any future gamma-ray burst would miss Earth, eliminating the supposed threat. Interestingly, this discovery has created a new scientific puzzle. How can the dust spiral appear face-on while the star's orbit is tilted? This contradiction challenges existing models of dust formation in colliding wind systems and suggests unknown physical processes may be influencing the formation of the dust plume. As Hill explained, this is such a great example of how with astronomy we often begin a study and the universe surprises us with mysteries we didn't expect. We may answer some questions but create more. Despite solving one mystery, confirming Earth isn't in the Death Star's line of fire, astronomers now have new questions about this fascinating stellar system. The research not only provides reassurance about Earth's safety, but also offers valuable insights into the complex dynamics of binary star systems and their evolutionary paths toward eventual supernova explosions. What an incredible journey through the cosmos we've had today. From the daring exploits of Parker's solar probe matching its record-breaking approach to our star at a blistering 430,000 miles per hour, to the newly launched Spherex telescope opening its eyes to the infrared universe. We've explored how EASY's trio of satellites will help us understand those mysterious electrical currents flowing through our upper atmosphere, giving us new insights into space weather. Perhaps most fascinating were those newly discovered space tornadoes swirling around our galaxy's core, violent streams of gas distributing materials throughout the galactic center in a cosmic recycling program of truly universal proportions. And how incredible that Chinese scientists have finally pinpointed the age of the moon's massive South Pole Aitken Basin to 4.25 billion years ago using samples from Chang'e 6, giving us a crucial anchor point in lunar chronology. We also looked ahead to NASA's Lucy spacecraft preparing for its April flyby of asteroid Donald Johanson as a dress rehearsal for its ultimate mission to Jupiter's Trojan asteroids. And I don't know about you, but I'm personally relieved that the binary star system WR-104, the so-called Death Star, isn't pointing its potential gamma-ray burst in our direction after all. I've been your host, Anna, and I want to thank you for joining me for this edition of Astronomy Daily. If you're hungry for more cosmic content, please visit our website at astronomydaily.io, where we keep our newsfeed constantly updated with the latest space and astronomy news. You'll also find all our previous episodes available for streaming. Don't forget to connect with us across social media. Just search for Astro Daily Pod on Facebook, X, YouTube, YouTube Music, TikTok, and Instagram. The universe is always changing, and we'll be here to keep you informed about every fascinating development. Until next time, keep looking up.